uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky. We've crossed the solar system and sent ships to the stars. But we continue to search. We can't help it. A central element of the human future lies far beyond the Earth. If we crave some cosmic purpose, then let us find ourselves a worthy goal.
This first image of a galaxy cluster takes us back 4.6 billion years, giving the deepest and sharpest infrared image of the distant universe to date. This graph, the most detailed of its kind, shows the distinct signature of water in the atmosphere surrounding a hot gas giant planet that is orbiting a distant sunlight star hundreds of light years away. In this image of the Carina Nebula, Webb peers through cosmic dust, revealing previously invisible areas of star birth. Covering about 1/5 of the moon's diameter, this is Webb's largest image to date, showcasing in rare detail a group of interacting galaxies known as Stephan's Quintet. And some stars save the best for last. Webb captured a dying star's final performance, sending out rings of gas and dust for thousands of years in all directions.
To test some of the modes to make sure that it wasn't too bright, to make sure that we could track Jupiter as it moves across the sky, because objects in our solar system move much faster relative to distant things. And so those were successful images, and you can see them here. Successful doesn't even say anything because they're beautiful. So as we said, we're going to study objects in our solar system, and for Jupiter, one of the very interesting things is the clouds and understanding the cloud structure, which pops out clearly in one of these images. And so this data itself just came out today, as all of the data from the past 6 months was released publicly today. Images, it depends on the image, but yeah, you can see the beautiful comparison with Hubble's image of the same field and Webb's. And as I mentioned before, this image of Webb took, I think it was total 12 hours, and the Hubble field took days. So really a very large difference for time that it took. For the other images that were released yesterday, they were all between 6 and 12 hours apiece, depending on the image. And yes, Webb is just as powerful as Hubble, and I think these images really show that they're complementary, and Webb has the beautiful resolution and added detail.
I mean, it's amazing. It's like going to the eye doctor and getting your glasses updated. You can see clearly now, and this is incredible.
I think the sun, the stars, the galaxies, the solar system and other systems are in the sky. And the stars are made of sunlight. There is heat and solar radiation and other elements.
Este telescopio puede tomar muchas fotos y bonitas.
Over the next year, there's over 1,000 people who are scientists who are going to use the data. And that's just people who already know they're going to use the data, and there's going to be a lot of more people who jump on it. It has only been possible with an international collaboration in all of these people, and it will, it's of 13.6 billion years. So to within about 150 million years of the Big Bang. And it's hard to put these numbers in perspective. Hubble has seen to about 400 million years after the Big Bang. Action pattern, that's actually still alive and well. It's a hot star. The one that only really appears in the mid-infrared image, that's the star that has died. They do gravitationally exert a lot on each other, but the explosion, and in this case, it wasn't quite a supernova. It wasn't quite as massive a star enough to make a supernova. But the explosion from the death of the first star, the material will pass by the second star, but it's not going to perturb it. However, the structure that you see and the fact that it's not just, a pure circle is because of the gravitational interactions between these two stars. And actually, what we learned from this image for the first time is that the star that died actually still has dust around it. It's dusty, which basically means it either didn't expel all of its layers, which is which would be really unique, or it might be pulling material from the other star. Anyways, we don't know yet, but they're definitely interacting in more ways than just gravitational.
Wow, a lot of mysteries to unpack there.
Completely new view. In order for us as humans to be able to look at these, we translate the colors. So basically, we just, if you think of colors like what we can see, A, B, C, D, and then infrared would be E, F, G, H. And so we just say that, instead of E, it's now A. Mm-hmm. And we just take infrared colors, which are wavelengths, and we make them into visible colors with our eyes. But if you look at an image, something that's red on the image is redder in space. So it's a real representation, but they are false color images because that's the only way that we could appreciate them. Otherwise, we'd show you a blank page and nobody would be very excited.
You'd be like, oh, okay, well, this is...